Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2022. Question number 6 is on the topic of forces. The distance a car travels during the driver's reaction time is called the thinking distance. Figure 9 shows how thinking distance depends on the speed for a car. So the line graph is a straight line going through 0. So which means the speed of the car in meters per second is increasing at a constant rate. When the speed increases, the thinking distance is also increasing at a constant rate. Determine the driver's reaction time. How do you work out the reaction time? From a distance and speed. Remember, speed equals distance for s divided by the time. So time, one second, we'll have to use the graph. So the thinking distance is 21 meters and that's 30 seconds or 30 meters per second. So speed is 30 equals 21 divided by time. Rearranging the equation, time equals 21 divided by 30 gives you 0.7 seconds. 0.7. Figure 10 shows how the velocity for a car changes during braking. So the velocity is starting at 30 and it decreases to 0 as time increases to 5 seconds. Determine the braking distance of the car. Now to find out the braking distance or distance from a velocity time graph is the area under the graph. So the area under the graph is basically you're trying to work out the area here. So the area for one box, 5 times 1 is 5. So if I count the number of boxes, 1, 2, 3, 4, let's say this and that is 5, 6, 7, 8, 8 and close to 9. Yeah, I didn't count that as well. So that's 9 boxes. So distance equals area under graph 1 square equals 5 meters. Total number of squares equals 9. So total braking distance is 9 times 5, that's 45 meters. Explain how the gradient of the line in figure 10 shows that the resultant force on the car was not constant. Now, if it was constant, it would be a straight line. It's actually curved. So the gradient is actually steeper at the start and then it becomes less. So remember, in a velocity time graph or speed time graph, the gradient is equal to the acceleration. So gradient is equal to acceleration. The gradient or acceleration is not constant, so resultant force is not constant because resultant force is directly proportional to acceleration for constant mass. That brings us to the end of question number 6, and I will see you in question number 7.